Welcome back everyone. In this lecture we will actually see many examples of rank 2 root system and we will actually try to classify them. So, for that purpose let us recall what we have done so far. So, we need to first recall the table that we have actually proved in the last class. So, that actually gives many restriction on the Cartan numbers and as well as the angle between the roots and so on. So, let us recall the table and then we will use that table in order to classify these dimension 2 root systems. So, as before take phi to be root system sitting inside this Euclidean space E. So, now what we do, we take alpha beta which is in phi. Okay. So, then we assume that this beta is actually not equal to plus or minus alpha. So, in particularly we assume that the dimension of this E is at least 2. So, now what one can easily check. So, this is something I will leave it as exercise. If we take phi and then intersect with this 2 dimensional space which is spanned by R alpha and R beta. So, that is going to be again a root system. So, this we denote it by let us say phi alpha comma beta. So, this is going to be a root system on its own. So, for example, like if we take this intersection, you can see that 0 is not going to be there since beta is not multiple of alpha. So, alpha and beta must be linearly independent. So, that means the span of phi alpha comma beta is going to be the Euclidean space spanned by this alpha beta which is 2 dimensional. And you can see that if x is in phi of alpha comma beta and Cx is there, that means C must be plus or minus 1. So, and again like if you take any reflection that comes from this phi alpha beta, that is going to leave this phi intersection R alpha plus R beta invariant. So, all the properties of the root system more or less immediate. Okay, the Cartan numbers again will not change. So, that also going to be integers. So, then it is immediate that this phi alpha beta is actually a root system. So, this is going to be 2 dimensional root system. So, now we most of the time if you are interested in understanding what happens between 2 roots and then like for example, we have seen in the last class how to deal with this alpha string through beta and so on. So, those informations you can actually get it from by coming down to this 2 dimensional root system. So, this is actually a general practice. If you want to know more about the combination of alpha beta, you come down to this 2 dimensional root system, just work with that 2 dimensional root system, that will be easier. So, now recall what we have actually done so far. So, the table that we have proved about Cartan numbers, so that is what important to us. So, if you recall that, so here is the table. So, let me draw it again. So, the Cartan numbers, the angle between alpha beta and this the ratio, all this will be recorded here. So, you take the Cartan number alpha beta, beta alpha, the angle between alpha and beta and the ratio between the norms. So, you can see that. So, there are some very few possibilities for these numbers. The first possibility is going to be 0, the second possibility is 1 and then minus 1, 1 2 and minus 1 2 and so on. So, we have the following thing 0 0, in this case the angle will be pi by 2 and then the ratio will be undetermined. And if alpha beta, if this is 1 and this is minus 1, in that case the angle is pi by 3 and then 2 pi by 3. So, then the ratio will be 1 1. Similarly, here the ratio will be 2 2 and then 3 3. So, in this case here 1 2 minus 1 minus 2 and then 1 3 minus 1 minus 3. So, these are all the possibilities. So, then we have the angle will be pi by 4, 3 pi by 4 and pi by 6 and 5 pi by 6. So, these are all the possibilities of angle and Cartan numbers for this alpha beta. So, here we have assumed that the norm of alpha is actually at most norm of beta. So, this is the assumption that we have made. The same assumption we will make it for alpha beta that we randomly picked here. Okay. So, here also we assume that alpha norm alpha is smaller than norm beta. So, now what we want to do, we want to actually understand the two dimensional root systems. We have seen that that actually help us to understand the root string root string between alpha and beta. Anyway, so let us see what are all the possibilities that we have. So, for that purpose we can assume that phi is being just a two dimensional root system. So, phi sitting inside E where dimension of E is 2. So, in particularly we pick alpha beta inside phi and then we assume that beta is not equal to plus or minus alpha, and then we can also assume that the norm of alpha is smaller than the norm of beta. So, these are all the assumptions that we are making. So, since beta is actually not multiple of alpha, you can see that E will be spanned by this alpha and beta. So, they are linearly independent. So, those things are also given. So, now if you go back to the table, you can see that what are all the possibilities. The very first possibility is that inner product is being 0. If the inner product is 0, so that is the case 1, then what we get? If inner product is 0, then that implies that this roots will be just plus or minus alpha and plus or minus beta. So, you can conclude that phi contains plus or minus alpha and plus or minus beta. Okay. So, then it cannot contain anything more. So, why that is the case? Because if it contains anything more, like for example, if you take some combination, then you can see that the inner product between those two combinations will be actually more. Okay. So, we will also make this assumption that this alpha beta they are chosen from phi, so that the angle between this alpha and beta they are the max possible. Okay. So, this alpha beta, so choose this alpha beta is in phi, so that the theta is the max. So, that means among all the roots that we have in phi, so this alpha beta, so those are all the roots that has actually maximum angle. Okay. So, now you can see that if you have for example, some combination of alpha beta is being inside phi, then if you compute that combination with inner product with alpha, then that will be non-zero. So, then that will force that the angle between those two vectors, okay, will be either acute or obtuse. Okay. In any case, if you replace that vector with its minus, then if the vector actually forms obtuse, then it will form acute. Okay. So, but anyway, like so that way, like you will be able to actually get more angled vectors inside your phi. Okay. So, that is not going to happen because we have assumed theta is the maximal angle possible. Okay. So, in this case theta is going to be pi by 2. So, let's just make it more precise. Let us say we want to claim that phi is going to be this plus or minus alpha comma plus or minus beta. So, otherwise what will happen? So, there will be a gamma which is in phi. So, now gamma is going to be some multiple of alpha times some multiple of beta. So, then you compute what is going to happen with the gamma alpha. You can see that this is going to be just I times alpha alpha. So, either I times alpha alpha is going to be positive or negative. So, if this is positive, okay, if this is positive, so then what will happen? The angle between alpha and gamma is going to be acute. But then if you take minus gamma alpha, so that is going to be negative. So that means the angle between gamma, minus gamma and alpha is actually obtuse. So in that case you can see that the angle is more than pi by 2. So that means we get more angle than what we already promised. So that is going to be a contradiction. So that forces that this phi must be equal to plus or minus alpha and plus or minus beta. So now let us look at the case 2. So in case 2, so again the above assumptions are there. So with that above assumptions you can see that because the angle is going to be max, so then this condition will not happen. Okay. If both the Cartan numbers are 1 1, then angle is going to be pi by 3. So then you can replace again alpha and minus beta. So then the angle will become 2 pi by 3. Okay. So that way we just assume that the angle between alpha and beta is going to be 2 pi by 3 and the Cartan numbers are going to be minus 1 minus 1. Okay. So we just take alpha beta to be minus 1 and then beta alpha to be minus 1 and the angle is going to be 2 by 3. So this is the max angle that we are going to have in the second case. So this case will not appear. You can replace because beta by minus beta, so that the angle becomes more. So then in this case you can see that this beta alpha is going to be the norm of. So what is given in this case? So the norm of beta square divided by norm of alpha square is going to be 1. So that means the norm of beta is same as norm of alpha. So that is going to give us norm of alpha is going to be norm of beta. So since alpha beta is going to be minus 1, you can see that if you take S alpha of beta, so you are going to get beta plus alpha, which is going to be inside phi. So this proves that you have plus or minus alpha, plus or minus beta and plus or minus alpha plus beta. So these are all in elements of your phi. So this is all elements of phi, but one can check in this case. So these are all actually already form a root system. So this set itself form a root system. So this is something one can check easily. So this is, I will leave it as check exercise. So this is going to be the case. So pictorially how it looks like? So it looks like, so you have this alpha and then let us say this is the alpha plus beta. So this is going to be alpha and this is going to be beta. So the angle is going to be 2 pi pi 3. Okay. And this is going to be alpha plus beta and this is going to be minus alpha plus beta and this is minus beta and this is minus alpha. So this is the root system that we are talking about. So now so this is what called type A2 root system. So we take this root system. Okay. So this is going to be called A2. So maybe just denote it by A2. So what is A2? So A2 is going to be minus plus or minus alpha, plus or minus beta and then plus or minus alpha plus beta. So this is the root system where the angle between alpha beta must be 2 pi by 3. So this is already a root system, that is I will leave it to you to check. So now we will see what happens in case 3. So in case 3 again you can see that because with our assumption the only possibilities that we have is 3 pi by 4, which will be the max angle. If this is the max angle, then these are all the Cartan numbers that we will have. So, in that case you can see that the angle alpha beta is going to be -1 and then angle beta alpha, that is going to be -2. So, in this case theta is going to be 3 pi by 4. So, then in this case the root system looks like. So, I can just leave it you to check. So, in this case, so you will have something like this, where alpha and alpha plus beta will have same length, and then you have this beta here, and you will have some. So, you can see that this is alpha, this is beta. So, this angle is going to be 3 pi by 4. So, now you can see that by applying this lemma that we proved earlier. So, since the inner product alpha beta is less than 0, so you can see that alpha plus beta is a root. So, that means this alpha plus beta, this is going to be your alpha plus beta. So, because S alpha of beta, sorry, S beta of alpha is going to be equal to alpha minus the angle alpha comma beta times beta. So, since the angle alpha beta is -1, this is going to give us alpha plus beta. So, this is going to be in phi. Since alpha and alpha plus beta, they are conjugate under this reflection. So, they should have same length. So, that is what we have done here. So, now if you use this alpha string through beta, you can see that this S alpha of beta is going to give us this element beta minus the bracket beta alpha of alpha. So, which is going to be beta plus 3 alpha, sorry, beta plus 2 alpha. So, that means the alpha string through beta is going to be, so beta, beta plus alpha and then beta plus 2 alpha. So, up to this is what we get. So, beta minus alpha won't be there. So, in particularly we get alpha, beta, because the angle between this alpha beta is obtuse. So, you can conclude that beta minus alpha cannot be again a root. Okay. So, for example, you can check. So, check beta minus alpha cannot be a root. So, that means, so these are all the only roots that we will have. So, alpha beta is there, alpha plus beta and then beta plus 2 alpha is here, and then their negatives minus alpha plus beta, minus beta plus 2 alpha and then minus alpha. So, these are all the roots. So, this root system is called B2. So, what is B2? B2 is going to be plus or minus alpha, plus or minus beta, plus or minus alpha plus beta, plus or minus beta plus 2 alpha, that is all. So, these 8 roots will form a root system. So, I will leave it to you to check that this indeed form a root system. So, this indeed form a root system. So, that is actually very clear from the picture, because the possible reflection that you can easily draw, and then you can see that this B2 will be invariant under all possible reflections, and Cartan integers are already determined. So, in particularly only thing need to be checked is that this has to be invariant under all the Cartan integers. Okay, so now if one can ask whether there is any more root in it. So, if we take for example any more root, then what will happen, like the largest angle we have fixed it to be 3 pi by 4. So, you can easily convince yourself using this picture that if you have any other root, then that root definitely will make more angle with some other root. Okay. So, for example, any other root, for example, if there is a root here, then the angle between this and alpha is going to be definitely smaller than this pi by 4. So, definitely the angle between this root and minus alpha is going to be more than 3 pi by 4. Okay. So, that is how you can see that you can't have any other root inside B 2. So, similar arguments you can give it for A 2 as well. Okay, I will leave it to you to check that, because that is something very important. You can get convinced yourself using the geometry. So, now again the case that is there at the end. So, where the Cartan integers could be this -1 and -3. So, that I will leave it to you to check. In that case, the root system will look as follows. So, for example, if we take alpha beta to be -1 and then the beta alpha to be -3, then the angle has to be 5 pi by 6. So, in this case what will happen, the root system which will be denoted by G2. So, this is going to be, so for example, like since this angle, sorry, the Cartan number is -3, you can see that S alpha of beta is going to be beta minus angle beta alpha alpha, which is going to be beta plus 3 alpha. This is going to be inside phi. Okay. So, I will leave it to you to check. Even in this case, we will have beta minus alpha is not a root. So, since it is not a root and this is the maximum root height root that we get. So, you can conclude that G2 has to be exactly equal to plus or minus alpha plus or minus beta plus or minus alpha plus beta and plus or minus beta plus 2 alpha and then plus or minus beta plus 3 alpha. So, these are all the roots that G2 can have. And since alpha and beta they make obtuse angle. So, the difference between alpha and beta cannot be a root. So, this actually proves that so these are all the only 2-dimensional root system possibles. So, what are they? So, the first one is alpha beta having orthogonal. So, that will corresponds to what is called A1 cross A1. So, that we actually drawn here. So, which is going to be just this alpha beta, where alpha beta are orthogonal. So, in this case this is going to be just denoted by A1 cross A1. So, in the second case, so we denoted the root system by A2. So, this is going to be denoted by A2, and the third thing is actually this B2, and the fourth thing we got G2. So, these are all the 2-dimensional root systems. 2-dimensional root systems, A1 cross A1, A2, B2 and then G2. So, I will leave it as exercise. So, this is a very important exercise. Check. So, we can talk about the dual root system of all this, okay? Because for any finite root system we have the dual root system. Since the dimension of E is 2, so the dual root system also will be 2-dimensional root system, but we just saw that these are all the only 2-dimensional root systems. So, that means if we take the dual of A1 cross A1, so that is going to be just isomorphic to A1 cross A1, and if we take the dual of A2, so that is going to be isomorphic to A2. If we take the dual of B2, and that is going to be isomorphic to B2. In terms of this G2, so G2 dual will be isomorphic to G2. Okay. So, this is what happens when you consider the dual systems. So, they are all self dual. So, this is something I will leave it to you to check. Okay. So, if you are interested in very concrete example of root systems, so let us actually construct one example. So, here is the one example which is very important example. What we can do, we can take this Rn plus 1. So, with the standard inner product. So, then take this phi to be, so these epsilon I minus epsilon j's, where this 1 less than or equal to I less than or equal to j n plus 1. So, all this epsilon I minus epsilon j you take. So, that is going to actually give us root system inside R n plus 1. So, note that this also can be identified inside. So, because the span of V we want. So, let us say let us compute what is the span of V. Even though this is living inside R n plus 1, you can see that the coefficient of some of the coefficients are being 0. So, the span of phi is going to be capital E, which is going to be those x in R n plus 1 such that if you write x equal to x1 etc. x n plus 1, then this x1 plus etc. plus x n plus 1 must be 0. So, this is going to be your Euclidean space. Okay. So, then you can think this phi as root system inside this E. Okay. So, this is what happens here. So, I just leave it to you to check this is indeed root system. So, the way we constructed, you can see that phi is actually finite, 0 is not there, and then span of phi is equal to E. So, what else we need to check? We need to check the reflections are actually going to leave phi invariant, and then if we take the Cartan numbers, then we will be getting integers. So, let us check what will be the Cartan numbers. So, if we take this alpha beta being elements of phi, then you can write it as epsilon I minus epsilon j comma some epsilon k minus epsilon L. So, this is going to be your Cartan numbers. So, this is divided by epsilon k minus epsilon L comma epsilon k minus epsilon L. So, this is going to be equal to, you can see that if I and j and k and L are different. So, then this is going to be 0 if I j intersection with k L. So, this is going to be empty, or otherwise what will happen. So, you can see that this epsilon k minus epsilon L comma epsilon k minus epsilon L is going to be equal to just 1 plus 1 2. So, that means this is exactly equal to epsilon I minus epsilon j comma epsilon k minus epsilon L. So, if you do the computation, you can see that whenever I equal to k, we get 1, and then minus whenever j equal to k, we get 1 minus, and then whenever I equal to L, we get 1 minus, and then we get plus delta j L. So, this is going to be the number. So, whatever it is going to be just 0 plus or minus 1. Okay. So, then in particularly it is going to be integer. So, that is very clear. Okay. So, the Cartan numbers are integers, that is very clear, and then I will leave it to you to check that if you take any epsilon I minus epsilon j acting on this epsilon k minus epsilon L, this is going to be again inside your phi. So, that is again not very difficult to check. Indeed, this is going to be just either 0 or plus or minus 1, that is also easy to check, that also I will leave it to you. Okay, I will stop here. So, we will actually continue with the theory of root system in the next class. So, indeed we will prove that the existence of base for root system, and then the existence of base in a way help us to actually define what is called this Cartan matrix as well as the Dinkin diagram. So, then using the Dinkin diagram, we will be able to actually classify all the finite root systems. Okay, I will stop here. Thanks.